Hi everyone and welcome back. Most beginners solve this problem using a hash set, but that wastes extra memory. In this video, I'll show you a cleaner two-pointers trick that solves it in a linear time with a constant space. Today, we are solving the lead code problem minimum common value. We are given two sorted arrays and we need to find the minimum integer common to both arrays. If no common value exists, we return -1. So let's look at an example. For example, if we have nums1 like this one and nums2 like the other one, then the smallest common value is 2. Now, the important detail here is both arrays are already sorted. And whenever you see sorted arrays, you should immediately think about either two pointers or a binary search. Since both arrays are sorted, we can compare elements directly using two pointers. One pointer for num1 and one pointer for num2. So let's make a dry run. Let's assume that I will be the pointer for nums1 and j will be the pointer for nums2. So initially I and j are equal to 0. So first we compare the first element from nums1 to the first element of nums2. They are not equal, and since 1 is smaller than 2, that means we move the I pointer one step forward. So we increment I to be 1. Now I is pointing to the second element, which is 2, and j is still pointing to the first element of nums2, which is also 2. They are equal. That means we found the smallest common value immediately. So we return 2. So why this algorithm works? The reason this works is because the arrays are sorted. If nums1 of I, like this example, is smaller, then it can never match any previous element in nums2. So we can safely move forward to the next element. So let's go through the code. First, I'll define the two pointer I and j, and both have the initial value of 0. Then we will start iterating over the two arrays. So at I is less than nums1 dot size and j less than nums2 dot size. This is to make sure that we are within the boundaries of the array. We need to check first if nums1 of I equal nums2 of j. So we check if the value under our pointers are equal or not. If they are equal, that means that we already found the smallest common element and we can directly return either nums1 of I or nums2 of j. So let's choose nums1 of I here. Second, we check if the element at nums1 of I is less than the element at nums2 of j. And that means that we can safely move the pointer of nums1 one step forward safely. So we will increment I by 1. Otherwise, we will increment j by 1. And if we completed iterating over the two arrays and we didn't find a common or smallest common number, then we have to return -1. So let's run it. And let's submit it. And in terms of time complexity, this algorithm run in O of n plus m, where n is the size of the first array and n is the size of the second array, because each pointer moves at most once through its array. And in terms of space complexity, it's constant because we use only some variables. And here is the important interview tips. Whenever you see two sorted array, think directly about either two pointers. These patterns appears everywhere in coding interview. And that's all for today's explanation. So if this explanation helped you, please subscribe to the channel for more clean coding interview solutions. And if you want the fastest way to recognize problem patterns in interviews, please check our next video. Thank you. Bye.